You can start.
Okay, so this is an in-hand training of the FTIR spectroscopy. So you know IR spectroscopy is one of the vibrational spectroscopy. So we put a sample in the spectrometer, irradiate IR beam, then the molecule absorbs and vibrational level, energy level is promoted to upper level from V0 to V1. And corresponding to that event, the intensity of the IR light decreases. So by comparing the intensity before and after the absorption, then we can calculate absorbance. So by checking the wave number dependence of the absorbance, we get IR absorption spectrum. So this is an instrument to get such a IR absorption spectrum. And usually we measure IR absorption spectrum in the transmission configuration. That is, put one drop on the window plate. Usually we use CaF2 calcium fluoride, CaF2, put one drop and flank with the another window. Then set in the spectrometer. Then very thin liquid film is formed here. And we can measure the IR absorption spectrum. This is a typical transmission IR spectrum. Today, here is IR spectrometer. And this is a little bit different configuration. So this is, we can choose ATR IR absorption. Okay, ATR is attenuated total reflection. So for this experiment, we use germanium prism, GE prism. Then irradiate IR light from the top of the prism. Then on the surface, at the surface of the prism, total reflection occurs, IR total reflection occurs and IR beam returns to original position. And this total reflection generates weak but stable IR light. This is a evanescent field. So IR beam is on the surface of the prism. Then we put the liquid sample below the prism. Then this liquid sample absorbs the evanescent field of IR light. So without preparing liquid sample, liquid film, we can measure IR absorption spectrum easily. The advantage of this method is that the depth of the evanescent field is always the same. So difficulty of the transmission configuration is that we need to make the thickness of the liquid film exactly the same always. Otherwise, so absorption, you know, there is a Lambert-Bell law. Absorbance is increases in proportion to the path length. So if the liquid film is thick, absorption becomes large. If this is thin, absorption is small. So if this thickness is not reproducible, we cannot discuss what is the meaning of this intense peak. Sometimes it's weak, sometimes moderately weak. So it varies, then it's very confusing. So it is a difficulty of the transmission configuration. And using this ATR setup, depth of the evanescent field is always the same. That is, path length is always exactly the same. So we can avoid that kind of difficulty in liquid film transmission method. So this is a relatively easier to get a reproducible result. So today we use this FTIR IR spectrometer. Okay. So this is an explanation about the instrument. And another advantage is that sample amount is quite small. Only one drop to touch with germanium prism is sufficient. Okay, and experiment finishes immediately because FTIR is very fast measurement. Okay, that is the advantage. And today I'm planning to measure sugar solution, aqueous solution of sugars, sucrose, glucose, fructose. Okay, so in today's talk, I explained there is a clear difference among the spectral pattern of the sugars. So please identify what is the similarity, what is the difference, and please realize it's distinguishable. Okay. Is there any question?
Can you repeat the difficulty of the transmission configuration?
Okay. So transmission configuration, we put one drop on the window and put another window, then set in the spectrometer. And here is a liquid film between flanked by two windows. And there is no way to control. I don't say no way. It's very difficult to control this length exactly the same. Okay? If there is one dust, it changes a little bit. Okay? If the amount of the volume and volume of the liquid sample is too large, it cannot approach. So it's difficult. So this difficulty affects the measurement because always we need to measure two spectra. That is solution spectrum and solvent spectrum. Okay, in order to discuss the spectral pattern of the solute, we need to subtract solution peaks from the solvent peaks from the solution. So we need to measure twice: solution, sugar solution, aqueous solution, and H2O. Okay, we need to do it twice. And we need to make it exactly the same length. It's difficult. In that sense, this is very advantageous. Any other question? Okay. Then, shall we start measurement or waiting for sample?
Sometime. Sample is
So now I ask student to prepare solution samples. So please wait for a moment. Okay. Sorry?
Software.
Software. Next. Now collecting background. So, just a moment. The measurement is going on.
This is a first. Yeah, backgrounding collecting point. So we need a sample now. Actually, sir, this is already open, sir. Now we require a sample. No, sir. We have taken it. No, sir.
Explain a bit about ATR attenuated potentials. Can you please explain a bit?
Sorry? Again.
Sir, can you please explain a bit about attenuated total reflectance, ATR? What is that?
Okay, so here is the interface between some material and air. Okay, so typically we use silicon or germanium, Si or Ge as a prism. So that is black brick for us in the visible region, but it's transparent in the IR region. So this is a prism. Then we introduce IR beam to germanium prism. Okay, then at the interface between the germanium and air, there the total reflection occurs. A total reflection is the event that occurs at the interface where the refractive index is not continuous. And when it occurs only when material refractive index of the material 1 is larger than material 2. So germanium refractive index is, I'm not sure, but air 1.0. And this is larger, so total reflection occurs. Then energy goes this direction, but at this point, an evanescent wave is generated. So that is the IR beam. It does not propagate, so it stays on the surface. So in that sense, it does not propagate, so it's different from this IR beam, but this is IR, has an energy of IR beam. Then when we touch the liquid sample here, then evanescent field is generated on the surface, and it is absorbed by sample. Then, by comparing the intensity of the light without and with sample, the energy of the total reflected light becomes different. So by checking the absorbed energy, we can get the information of the IR absorption. So instead of propagating IR light, we use evanescent wave. That is a principle of the ATR measurement. And this penetration depth of the IR light depends on the wavelength. So we should be aware of the difference between transmission measurement and ATR measurement. In the case of transmission measurement, path length is always the same, determined by the distance between two windows. But in the case of ATR, penetration depth of the evanescent wave depends on the wavelength. And 40,000 wave number correspond to 2.5 micrometer. Wavelength is 2.5 micrometer. 400 wave number correspond to 25 micrometer. So 4,000 wave number IR beam penetrates short distance. 400 wave number light penetrates long distance. So the path length is different for each wavelength. So when we compare the ATR IR spectrum and IR absorption spectrum with the transmission configuration, some intensity pattern is distorted because of the difference in the path length. So we need to be aware of that feature. So in the small region, that effect may be nearly negligible, but if you show whole range, you should consider that character. Sorry. Yes and no. Yeah. First, right? Yes. Would you do it? I'm not familiar.
अरे वो उधर उधर ये माइकल कंप्यूटर है
Is there a box? Tip box. How much sample did you put?
One drop.
One drop. 10 microliter or so. Very small amount. 10 microliter is sufficient for one measurement. Then now he touches the prism to liquid sample. So how many times, what is the number of the accumulation? How many times do you scan?
Checks.
So during the measurement, please record your experimental condition. So resolution and accumulation number is very important. Okay, can you see? Please have a look at this result. Okay, can you see? Okay, so here is this is ATR-IR spectrum. So the range from 0 wave number to 4,000 wave number is shown. And this is a transmittance spectrum. Vertical axis is transmittance. So in principle, the number should be between 0% and 100%. And this region is very noisy because germanium prism is not transparent in this wave number region. Okay, so IR spectrum is measured, calculated by the equation. Absorption is minus log log I over I0. And in this case, I0 is almost 0. Then 0 over 0 diverges, and that kind of diverging is seen in this region below 600 wave number. And so it may be a good idea to limit the region above 600 wave number. Then it looks clear, right? And transmittance gradually lowers, so the transmittance is gradually lowering right now here. And you see this is the OH stretching mode of H2O. This is water. And this is HOH bending of water. Okay? And it should be nearly 1000. What is a prism? Germanium or silicon? Silicon. Okay. In this case, prism was made of silicon. Then the peak nearly 1000 is attributed to SiO stretching. So SiO, silicon is a SiO2. So absorption of the silicon prism also is also observed. Okay, so this is the so-called solvent spectrum. In order to measure solvent spectrum, I0 is air and I is water. Then I get a spectrum of water. In the next measurement, we replace a sample from water to sugar solution. Okay, then we will see some additional peaks in this screen. Okay, this is water, so only H2O, OH stretching and HOH bending is seen. Okay, so this is the first step. We finish the measurement of the solvent. Okay.
There is no peak of sucrose. There is mainly predominates by water. No? The spectra is mainly predominant by water. So, what about the sucrose? Sucrose vibration.
This is sucrose solution.
Yeah.
So then we should
Increase the concentration.
We should measure water first and calculate the difference.
Okay.
Water. Excuse me, it was the measurement of the sucrose solution already. So we should find some peaks of sucrose here. Okay, and this is apparently small peak. So we need a careful measurement. Okay, so would you measure? Please heat up and put in the hot water and solubility increases, so you can prepare a high concentration sample. Okay, just a moment. So, would you measure water spectrum first? Okay, again, let's measure the water spectrum as a first step.
So can we divide it in three parts, because many students are backside, they are not able to see. So let's make it in three groups.
Three groups. Yes.
Two groups, we'll keep them engaged with these two students, so that
break it in 3 groups. So first group will do IR and Professor Hiromasu will do that. Second group will do invisible and third group will do frozen. And he will give 3 times. We all will give 3 times.
It's okay. It's okay. Thank you.
Instead of just discriminate. So come here for invisible, come here.
So this instrument we can't increase the acquisition time. So it is. So there is no option to increase the time acquisition or accumulation time.
Sorry?
So there is no in the software. There is nothing to increase the accumulation acquisition time.
So it is fixed.
Fix.
So
This is the problem here.
I see. And what is the accumulation number? 500 or 1000 or
I don't.
Scale settings से लेके सब कुछ. So जैसे प्रोग्राम आपने स्टार्ट किया ना till the end कौन सा प्रोग्राम हुआ क्या?
Okay. So this is a spectrum of what?
Yes, water, but doesn't come in reverse of fluid whatever is.
You measured
But
I0 with this condition.
but this is water, right?
Water.
This is water, right? So white band will occur.
So if I0 is air, then I is water, then we will find the water signal. If I0 is water, I is water, then always is
Okay.
the same 1.0.
We should clean this one also, the germanium crystal. We should keep germanium crystal also clean.
We should remove.
Soaking.
Gently.
Maybe for this.
No, this is I0, so with air. Let's proceed.
So we clean this one now.
Now green. So this is measurement of air
Yeah.
as I0.
Yeah.
So this measurement consists of two measurements. One is the measurement of the water spectrum, solvent spectrum. The other is the measurement of the solution spectrum. So usually we measure solvent spectrum by measuring scanning twice. First scanning is measurement of I0 without sample. Then putting solvent and measure I. Then we get a spectrum of solvent. Again, I0 is air, I is solution. Then from these two scans, we get a solution spectrum. After getting two spectrum, we subtract solvent from solution spectrum. Then we will get solute signal.
Excuse me, sir.
Yes.
So if we are putting a sample and then what we are getting in the form of spectra, that will be a solvent spectra.
Sorry?
If we are putting sample,
Protein sample.
protein sample or any sample, then it would be the solution spectra or solvent spectra because it is mixed in water only.
So solvent is water, and solution is prepared with water. So we measure both.
One, for the first time we measured I0, which is without any sample. Second, we measured the sample. So the spectra come after putting the sample will be solvent spectra or solution spectra.
Protein spectrum appears in the solution spectrum.
Okay. So because we need to subtract the solution spectra from this solvent spectra. We need to subtract the solution spectra from the spectra which is with
We need
air.
to subtract the solvent spectrum from solution spectrum. Solution is solvent plus solute, and solvent.
Okay, okay, got it.
Subtract.
So we need to measure this individually. In case of solvent spectra, there is no sample, just the I0 is air.
I0 is here.
How did we measure I0? How did we measure I0?
So this prism was at this position, and then it measures air because there is no sample, X sample. Then that is I0. And now, you see, again, this is a spectrum of water. OH stretching appears, HOH bending appears, and this region is not transparent with this prism. So this region diverges. So this is a solvent spectrum. This is this region. So here is a prism, silicon or germanium. Then it is in general transparent in the IR region, but this is the lower limit of the transparency. So in this region, the IR light below 600 wave number does not pass through the prism. Then this is a measurement spectrum obtained from I over I0. But I0 is 0, I is 0. Then in this region, 0 over 0 is converted to transmittance. So it diverges. So please be aware which region is available. Both I0, I.
So this is only water, nothing in it.
So prism, absorption of the prism.
The sample contains only water, nothing else.
For now, this is water. Then would you save this data? Would you save this data?
It is water.
And would you save?
Oh, save.
Export. And do you save to this? Anywhere is okay. Yes.
Which file? CSV or Excel?
CSV.
CSV.
Okay. Then it's time to move to the solution spectrum. So already I0 is air. So let's share between two measurements. I0 is air. I is solvent or solution. So replace the sample to
Sucrose in higher concentration.
higher concentration. Yes.
So you are telling that I0 will be air
I0 is air.
and I will be either for the solvent or the sample
I in the first measurement I is
for solvent,
solvent.
and now we are taking it for the sample.
Right.
So I0, you told in the first case I0 was 0, for which we were getting the noise in the spectrum.
I0 is a measurement of air.
That was 0.
So, the first time,
That is I0.
that time we did not put the sample. We already put the sample and then take the ISO. So that is why there is no spectra of water. So next time we taking the spectra I0 of air, then we are taking the water.
So
Then
actually, I0 is related to incident or transmitted light, or it has to do with the air and the change in the reflective
not
index.
absorbance, it is reflectance. In I0 and I, what you are telling, it's about absorbance. You are thinking that I0 is light coming and IT is light. That is not the case.
So I'm not.
It is the change in the reflective index.
Yeah,
I'm
it's
not.
the change.
In the spectra, there was a portion where it was noisy. So sir told that just because I0 was 0 there.
Both are zero.
After 400, no? After before 400,
So my
400.
question is that sir is telling that in the first case I0 was air, in the second case also I0 will be air. So in the second case also we'll be getting that noise in that spectra.
This is due to the germanium crystal. So at
But
that
there is
particular
silicon.
region, that is silicon or germanium, which one is the crystal is, at that region it was not fully reflected. Complete reflectance is there. So that's
Means in every case at that point, that 12 number, there will be no reflections for air.
for the particular this crystal which we are using, it depends on that.
Okay, either germanium or silicon. To be clear.
We call it a spectral window. Which region is available for the spectroscopy? So if the window absorbs or shuts out light, then measurement is impossible. So we can record the spectrum only in the spectral window. In this case, above 600.
नीचे वाली सारी चीजें वो नॉइज की तरह अटैक करेगा कि वो विंडो भी इसकी 600 से
Oh, it depends on the particular window.
हाँ वही
So
सब
it also depends on the crystal which we are using.
ये केस में तो I0 बता दिया गया तो मतलब I0 हमेशा
zero by something is infinity. So the पूरा से ऐसे भी खर्चा नहीं लेकिन सीधा दूसरा उसी रीजन में 400 आइडियली
So this is the second measurement of
5 molar concentration.
5 molar.
5 molar concentration आइडिया रहता है ना इतने concentration में ऐसा है सही नहीं लिखा है मैं उल्टे हाथ से देखती हूँ
Next.
भैया बिल्कुल स्केलिंग वगैरह
ये ऑटोमेटेड है लेकिन काल विक्रमण है उसमें स्केलिंग में सब कुछ उसमें
मतलब इधर हम लोगों ने कुछ एक्स एक्स वाई एक्सिस सेट नहीं किया
ये ऑलरेडी ट्रांसमिटेंस के लिए है तो एक वाई एक्सिस ट्रांसमिटेंस है एक्स एक्सिस कोई नंबर है
हाँ मैं बोलूँ मतलब स्केलिंग डिपेंड नहीं कर सकते हम लोग अकॉर्डिंग टू आवर कन्वीनियंस एक बार वो दिखा दीजिए और बेसलाइन से
यहाँ पे तो बेसलाइन सेट है अगर बेसलाइन सेट करना तो डेटा लेकर वर्जन सॉफ्टवेयर आता है उसमें तो बेसलाइन सेट
Okay, you see the spectral pattern is quite different. Okay, the solvent is water and salt is sucrose and concentration is 5 molar. Okay, then as we see in the solvent spectrum, OH stretching appears here and HOH bending appears here. In addition, there are several peaks. You see, right? So this is there is a peak below 3,000 wave number. So this is assignable to the aliphatic CH. Above 3,000 it's aromatic. Below 3,000 it's aliphatic CH. Also, near 1450 wave number there is a absorption peak, and this should be attributed to CH bending. Okay, and these strong peaks, one of these strong peaks should be attributed to CO stretching, or CC. CC does not appear in IR. So anyway, we find the difference between solvent spectrum and solution spectrum. Okay, so let's record data. Then where was it? Here?
Yes. So change the name.
No response. Export. Okay. pathway. Yes. Okay, so we finished the two measurements, solution spectrum and solvent spectrum. So it's time to check the difference between them.
Yeah.
And is there any application on this PC, or I shall use my own? Okay, just one moment. Can I pick up? Oh, sorry. Can I move to CSV data? Okay, let's move all to data. Directly. Okay, thank you. So it's time to do the analysis. Can you see? I'm not sure if I can hold it. See, it's pretty fine. CSV.
So you are using Eagle?
Eagle.
Yeah.
सर ये जो आपने डेटा दिया वो किसी सॉफ्टवेयर से खुलता है या फिर ग्रामीण
खुल जाएगा सब में, वो CSV फाइल है, मतलब प्लॉट सॉफ्टवेयर से.
Okay, so this is the solvent spectrum. As I explained, below 600 is not available, so let's erase from the screen. Okay. This is a solvent spectrum. Oh, just a moment. Then the red spectrum is a solution. 5 molar sucrose. Okay, then so this is a different spectrum. And axis is separate. You see, this is the absorption transmittance spectrum of sucrose. Okay. Actually, how can I do?
Sir, is there any way we could get peaks in the number?
Sorry?
Is there any way we could get the numbers as well on the plot? So we could pinpoint the exact
Like
wave
different
number.
dips will have a particular wave number which can be denoted in this spectrum only.
Wave number?
So these wave number can be represented so that we know the exact wave.
Okay. So, and it indicates this peak is 1014. Just a moment, let's assign, identify the peak position. Notation, Q. Okay, this peak is 1064. And the right hand side is 991. Okay. The cursor and checking the peak position, you can identify what is the wave number. Okay, do you see? So black is the H2O solvent spectrum. Red is a solution spectrum, 5 molar sucrose. So you see there is a clear difference. So this part corresponds to CH stretching. And this part corresponds to CO stretching or CO stretching or some torsional motion, rocking motion, or wagging motion. And 1450, this is CH wagging. So probably you can imagine what is the sugar structure. It consists of a 6-membered ring or 5-membered ring, consists of C, 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 O. So it is filled with CC bond and CO bond, CH bond. And the peaks assignable to these positions are seen here. Okay. So by calculating a difference between red and black, we find where is the peak. So they are all assignable to sucrose. Actually, this region is a little bit unstable. stable. And because screws form the new hydrogen bonding with water, solvent water. So the solvent bond is also a little bit affected. Okay, ideally, if there is no solvent-salt interaction, this peak does not change. This peak does not change accordingly. Only the signal of screws should appear on the blue spectrum. But solvent is also affected by screws. So the peak shift or change is. So this is a measurement of sugar spectrum, screw spectrum. Okay. Then.
So how you have overlapped the two spectra? Because initially we were seeing only one spectra, then you overlapped the another one, the solution and the solvents.
Two?
Yeah, you overlapped. Then
baseline of these two, black and red, should be 100%, and absorption occurs, so it becomes negative peak. It is a transmit.
how this the software works, like how your is visible now. All three spectra is in a single graph.
So this is depends on each application. So put together, display and append to graph.
Okay, because you have done such in coding, we didn't understand that. What the overlapping only now.
So just a moment. How can I say? So I use the display and append to graph. Then it appears in the same graph. Okay. So please try. Okay. Someone try.
Can we get this different spectra by plotting this plot in origin directly, subtracting from A to B?
Sorry?
This different spectra.
So I calculated diff is equal to.
My question is, can we get this spectra by using origin? Origin factor?
I have never used origin, but
So just subtracting the y-axis, we can get it.
Actually, I'm not satisfied because blue is a difference and vertical axis is baseline is 0 and peak is negative. But in principle, baseline should be 100%. So we need to be careful about this operation. So I will set other offset to make the baseline to 100. Then it makes sense. But I think this kind of graph can be made using any software analysis, data analysis software. So please try it. Okay.
So the exported file that we got, did we get it in a CSV form? Did we only have all the plot points? So we could have used any plotting software to draw the graphs. We only got it in pure CSV form. Right.
So there must be some extension or it depends on the software, but several Excel file, JCamp, or various is possible. Okay, do they have a chance to try this experiment or only watching? Okay, is there any questions?
You see now you have seen that
Hey.
No, I was asking if might be silly to ask, but do you remember what each of the peaks correspond to? Is it from your experience that you say, or is there some kind of pattern to determining what each of the peaks mean?
So this peak it appears, just a moment please. Okay, 3000 is here. Maybe it's clearer. Three thousand wave number is here, and here is the depression. It corresponds to the absorption peak, and the absorption near 3000 and below 3000 is aliphatic CH. If this peak appears above 3000, we should regard it as an aromatic CH. Okay, and here this term. Here is a peak, probably 1450 or somewhere. This is CH bending, and I'm not sure. One of these peaks should be CO stretching, or there must be COC bending, or some other vibrational mode must appear here. And so, when we want to know what is the real exact assignment, one method is to check the literature. Okay, this is not a new compound, so someone must already study peak assignment. Next, if this is a new compound, please consider to introduce stable isotope. Okay, then carbon-13 or deuterium. Then peak shift. If this is CD, then it should appear at 2600 or so. Then we see this is CH stretching. So if the effect of the stable isotope labeling is as expected, then it supports your idea about the assignment.
So, is there some kind of program or algorithm, some application maybe, that can identify an unknown compound spectrum?
You mean a database?
Yes, sir.
No, rather than database, a database would match the values, something to identify a new spectra. Perhaps it could have the information for all the existing?
Probably no such a, there is no such a convenient one. So we need to discuss and conclude, and always someone asks, is that true? We think this is true because.
It's a manual check.
Then the consensus will be established. Long way.
Okay, thank you, sir. Okay.
Just thank you. Okay, again I should explain what we are doing. So in this experiment, we will get the spectrum of the sucrose in water solution. For that purpose, we need to record two spectrums. One is a solvent, the other is solution. Difference is a solute. Okay, by subtracting spectrum, any part is assignable to the solute, sucrose. So we record two spectra. And to record one spectrum, we need to scan twice. One is I0 without any sample, and the other is I with sample. Then I over I0 is related to absorbance or transmittance. So 2 scan gives 1 spectrum, 2 scan gives 1 spectrum. So today we need to do 4 scans. Okay? I sample and FTIR crystal is here. So it is touched to air. So no sample. Okay, we need to be patient. It's fast enough. So when I was a postdoc, I accumulated the data for 8 hours. And in total 32 hours, I get 1 spectrum. Okay.
Accumulation of 8 hours. Accumulation of 8 hours.
8 hours overnight. Higher wavelength, wave number region, low region, solution, solvent. So 32 hours. Okay, please look. So 10 microliter of the water solvent is put on the crystal and fixed. Then the measurement of the solvent spectrum starts. In this case, the solvent is water, so we can expect 3 peaks, 2 OH stretching and 1 OH bending. Okay, and please realize there are 3 peaks. Okay, you see, this is a result. So the region from 0 wave number to 4000 wave number is shown. And there are 2 peaks, OH symmetric stretching and anti-symmetric stretching. So it overlaps due to the high and strong hydrogen bonding effect. And this is OH bending bond. Below 600 is very noisy. It's because the prism does not transmit IR light. So we measure this spectrum by 2 scan I0 and I, and both I0, I is equal to 0 in this region. So 0 over 0. It is. So this is unstable, and this region is not available. Oh, return. Is it? And so let's make focus on valid area. Okay. So already the transmittance is getting lower, so the transmittance is poorer due to the prism. Then first measurement finish. This is solvent spectrum. Then next is the measurement of the solution. Difference is if the solute is present or not.
What is the reference of these small peaks?
This?
Yeah.
I'm not sure. Just a moment. Actually, H2O is a 3-atomic molecule, so 3n minus 3. So 3n minus 6, we expect 3 vibration modes. But in the liquid phase, H2O is different from gas phase, so they form hydrogen bonding, so they cannot be isolated from each other anymore. Accordingly, they form some unit structure. And so here is 5 H2O forms one unit. Then vibration mode of 5 unit is detected here. One of the unit vibration appears at 2200 wave number. So that is characteristic to the liquid water. So I think that peak is observed. But due to some transmittance problem of the prism, some small feature.
Is there any effect of air particles?
Air particle? No. Actually, during the IR measurement in the transmission configuration, don't talk. The vapor from my mouth affects result, and vapor peak increases.
It's fructose now.
Okay, fructose. Let's
now you can.
Fructose.
We are doing fructose.
So the sample is fructose 5 molar.
Yeah.
So does change in concentration affect in any way? Like does the intensity changes if I change
Intensity changes.
anything other than that?
So if there is intermolecular interaction between the solute, then peak shift would occur. So it depends on the concentration. 1 millimolar, probably no problem. But 10 molar, 20 molar, there must be some interaction.
So how do you decide like the ideal concentration?
All we can do is to explain at this concentration result is this, and you may check the concentration dependence and examine the possible effect of the concentration. If the peak shift occurs at a higher concentration, but it stops at some certain concentration, then below this concentration is safe to show. This is a representative spectrum of this solute. You put the sample here during I0 measurement.
That time this one is on that side.
Let's see what happens. Probably prism is at the bottom. And this part ensures that attaching of the sample to the prism. Okay.
During measurement, since the width of the film, we cannot ensure that it's always used. So will that hamper our experiment? Like, will that cause any effect since the width is not same every time we measure it? Sir, the width of the film, since it's not same, so will that affect our measurement?
It may affect. So in particular, the distance from the prism affects the absorption intensity. So please repeat experiment many times, at least 3 times, and this is reproducible result.
Does not count.
Okay. Okay, there was a small mistake, so let's challenge again. Well, you may measure the I0 spectrum twice. Once you measure I0, but I'm not sure. Every time you need to measure I0 and I, probably. Okay, the sample is 5 molar fructose solution. And 10 microliter is put on the prism. Okay, do you see? This is a measurement of 5 molar fructose. Again, below 600 wave number is not available. So we call it a spectral window. If the window material absorbs the IR light, that range region is not available for spectral measurement. So this below 600 is absorbed by the prism. Permanent license. So, but it depends. Annual subscription is recently available. So in my case, I purchased permanent license.
Sir, it's learning, student learning edition is available. Student learning edition is available.
Student discount is. So recently abolished, so I didn't check. I'm not a student already. Product. Just a moment, trial by. Student price is available. Academic or student. Oh, discount is $75 US. Oh, I purchased with 85.
Plus VAT, sales tax.
That's it, but it may be more convenient to use the same software in your laboratory because someone teaches you how to use. In my laboratory, we use this, but it depends. Anything is okay.
Fluorescence भी होगा।
ATRIR, attenuated total reflection.
Sir is telling them to do themselves. So you can do yourself.
Is there someone who want to operate? Just a moment, just a moment. So this is a holder to push the sample onto the prism. Just a moment. And please wipe and clean it. Don't scratch. Please push and okay. Also, would you give me one paper? Be okay. This part should also be clean. So do not wipe. Do not strongly.
Only push.
Only immerse. Fit. Then what is necessary for one measurement? I0 and I. Twice time. So I0 should be measured at this condition. Without sample, I0 is measured. Then now the measurement is underway.
Sir, why collecting background signal is important? Sir, why collecting background is important for the analysis? For calibration or any other thing?
So there appears many peaks. The part of the peaks are those of the solvent. So in order to identify which is the solvent peak, we need to measure solvent spectrum. Then put the sample here. Okay, let's try this glucose. Please put always the same volume. And please cap. And can you see? Okay, so gently rotate and approach. Okay. Already you see some negative peaks around here. It is not seen in the solution spectrum, solvent spectrum.
when we record the next sample, we need to do a for I0 scan.
I0 scan is air.
Yeah, every time.
So as far as using this software every time. So
So what is the detection limit of this system? The detection limit?
Detection limit.
Detection range.
Detection range.
For
any component.
So it is determined by the ability of the detector, and so it depends, but usually 6,000 or 7,000. If MCT, mercury chromium telluride is used, MCT detector is used, then upper limit is 6,000 or 7,000. But in that case, some Fourier transform becomes confusing, so we need to make a special care if we measure long range together.
So what about prism like silicon, as you silicon prism and germanium prism? What aspect we can difference silicon or germanium prism?
So the refractive index is different. Then accordingly, the total reflection angle is different. Then the penetration depth becomes different. So using germanium and deeper region will be monitored. I remember. And chemical stability is different. Probably germanium. But silicon is stable enough. Just a moment. You should save the data. Okay, next person. So please fit and remove the data, remove the sample. Do not scratch. And also this part is fit. So the first measurement is I0. Air. So the biggest mistake during the experiment is to fail to save the data after a long time accumulation. Today's experiment finished. Go home.
We measure water.
No.
Then we measure fructose.
No, already I have data of water.
Only initially starting.
Let's measure glucose
Directly. We have.
So if this is your experiment, independent experiment, you should measure solvent and solution. And already we have the data of the solvent, so only solution.
When we take solid for analysis, when there is any difference in peak intensity or other else?
Actually, the absorbance has physical meaning by itself, so there is no standard necessary. Absorbance 1.0 means I is 10% of I0. Okay. Then shall we go to next?
Sir, what is the superiority over FTIR or this IR? So what is the superiority of FTIR and ATIR?
ATIR. This is very convenient and sample preparation is easy. But as I explained, penetration of the evanescent field depends on the wavelength. So even though we get a spectrum depending on the penetration depth, so if the wavelength is long, then penetration depth of total wavelength is short. The path length depends on the wavelength. So FTIR spectrum is like this. So it's okay to identify the peak position, even if intensity is distant. So the problem, then this is very convenient, much advantage. If the intensity is very important, then transmission measurement should be safer. Okay, then finish. So export CSV and name is 1 molar GLC. Fructose.
FIU-CTOSC.
Yeah, glucose. This is glucose.
This is glucose. So glucose. Overall, these peaks shows the resemblance of vibration at the molecule. Sir, these vibrations are phononic vibration or normal vibrations?
Normal mode.
Normal vibrations. So in solid, we can capture the phononic vibrations of the sample.
In solid.
There is some. That Atmosphere had used the approach to use the big molecule to stop the recoil.
In the case of solid, discussion is somehow different. So phase is important.
Phase is important.
Then glucose. Down. Let's move to PC and let's do the analysis. When the measurement finishes, please move your PC. Okay. have measured fructose and sucrose and water. So you add your data to this list. Okay, fructose, sucrose has been already measured.
Can we detect in isomers of RNS form of this fructose and glucose? For in this form, can we say R and S form can be?
R and S.
Like normal IR, we can differentiate.
Yep. Peak position is different. So if the structure is different, then peak position is quite different. So galactose and glucose are monosaccharide, but spectral pattern, only the direction is different, but pattern is quite different. Where was it? One more. Okay, you see this is glucose spectrum. Glucose. So black is orange glucose, red sucrose, blue and green fructose. So even though the structure is similar, pattern is quite different. So subtract the water spectrum from orange. So here.
Calibrate
So green is glucose, absorption of glucose. Okay, so in the case of sucrose, no, fructose, pink spectrum, there is a peak, only one peak here. And sucrose, there are two peaks. And green is glucose. So depending on for three sugars, intensity pattern is quite different. Okay, so for now I cannot say what is the origin of this. We want to know. Let's check the literature first. Okay, so as far as this is not a brand new molecule, there must be some information in the literature. And also, in order to make sure that assignment, we may introduce a stable isotope to induce a peak shift and make sure if that is expected shift or not. Then we can confirm the assignment. Okay, that's it.
I will work on surface in an infrared absorption spectroscopy enhance the vibration rate of molecule using FTIR. Surface plasma resonance.
Surface. You mean source?
Surface or similar surface in an infrared absorption. Similar.
That is quite different. This is using the evanescent field. So the total reflection and standing wave is generated. So this system uses standing wave on the surface of the prism. On the other hand, source utilizes the plasmon strengthened electric field on the